Greetings, pre-calc students. We're going to continue our examination of inverse trig functions with one of the things that a lot of times people can kind of get confused about, which are compositions. So we're going to kind of go over a couple different examples. When it asks for a composition of the tangent of the sine inverse, it helps to remember what's our domain and what's our range when we're looking at functions and their inverses. Our domain for the inverse functions is some ratio. So what it's saying is when we look at just the sine inverse of negative 5 over 13, it's saying, hey, here's this input of 5 over 13, negative 5 over 13. It's going to kick out some range, something in our range. Our range in this case, our range for sine inverse, are angles. This, as crazy as it looks, is an angle. Sine inverse of negative 5/13 is saying, give me the angle that gives me a sine ratio of negative 5 over 13. So then when we add this extra element of what's the tangent of that, it's just saying what's the tangent of this angle. Because this kind of looks crazy and we don't really want to deal with these, well, let's say that we're looking for, in other words, we're going to rewrite this. Sine inverse of negative 5/13 we're going to call u. When we're asking for the sine inverse of negative 5/13, what we're going to say is that we're looking for some angle called u. So what we're going to end up having, what we're asking is really what's the tangent of u. Now, the reason why we did this u substitution is so we can have something a little more concrete to work with. If sine inverse of negative 5/13 equals u, I'm going to take the sine of both sides. What happens is the sine of sine inverse of negative 5/13 equals the sine of u. Because negative 5/13 falls within our domain of negative sine inverse, what that means is the sine and the sine inverse functions will cancel with each other, leaving us with the expression of sine of u equals negative 5/13. The reason why we wanted to do this was so that we can draw a triangle. For sine to be negative and still be within our range for the sine inverse, we know that this triangle has to fall in quadrant 4. So the sine of u will be opposite negative 5 over hypotenuse 13th, and here is my angle u. What's great about this is we can use Pythagorean's theorem to come up with this triangle. Pythagorean's theorem will yield that this side is 12. So we do all this point to find this triangle, and it's like, great, how does this triangle help? Well, let's go back to what we originally wrote. We're looking for the tangent of this angle u. Like we said, sine inverse of u kicks out some angle. Well, because we're looking for the tangent of that angle and not what the angle is itself, we don't need to run to our calculators. We can plug it in right here. The tangent of u will equal the opposite over the adjacent. Opposite of u is negative 5. The adjacent is 12. So the tangent of u equals negative 5/12. The u, we said, was the sine inverse of negative 5/13. So the tangent of the sine inverse of negative 5/13 equals negative 5/12. You'll get a bunch of practice of those in class. I know that all of our pre-calc teachers are probably going to hit these pretty hard. Next, evaluate the expression tangent of the cosine inverse of x over the square root of x squared plus 16. It looks big, it looks intimidating, but we're going to follow the same process. We're going to say that u equals the cosine inverse of x over the square root of x squared plus 16. The reason why we're saying that is because u is just some angle. We're just looking for the tangent of whatever this angle is. In order to help us set up this triangle, we're going to take the cosine of both sides, and we get the cosine of u equals x over the square root of x squared plus 16. And we're going to draw our triangle here. Now in this case, it's going to be a little bit more difficult. We don't know if it's negative. We don't know if it's positive. So let's just say that this is all in quadrant 1. I think in your homework, in your books, they tell you, they restrict where it's coming from, whether it's positive or it's negative. So in this case, our cosine is adjacent x over hypotenuse, which is the square root of x squared plus 16. This is our angle u. I'm going to write out Pythagorean's theorem rather than just saying what it is. But we're looking for some sign opposite. And the reason why is because we're looking for the tangent of this whole thing now became u, which means we need the opposite and the adjacent. The adjacent we have is x, which is nice. But we need to figure out the opposite. When we use Pythagorean's theorem, we're going to get x squared plus the opposite squared equals the square root of x squared plus 16, that whole quantity squared. This gives us x squared plus the opposite side squared equals x squared plus 16. Now that we kind of see it out, it's like, oh, that's maybe not as bad as we thought. The x squareds cancel. The opposite squared equals 16, which means that the opposite side is equal to 4. So when we are looking for the tangent of u, which is what this whole thing is, here's our little u angle. Tangent of u will equal opposite, which we said 4, over adjacent, which is x, and all of that math just to get a final answer of 4 over x. Now, no, I kind of like it. I know a lot of you are probably cursing me silently under your breath, but that's all right because I'm still having fun. Enjoy it. We got one more video for trig inverses.